So, we just talked about our rules for how we assign oxidation numbers. Remember, most of them are pretty close to how we assign charges, but you're going to find some of them really aren't. So make sure you follow your rules and make sure you follow them in order. So here we've got potassium chloride, right?
Right.
Okay, so which rule is the first one that we'll apply here? Because our very first rule is about free elements. Do we have any free elements here?
No, they're two elements, but they're two different elements put together, so they're not free. So then the next one is looking at the periodic table.
Yes, because for metal ions especially.
Okay, so all right, K potassium is our metal, so I can look at the periodic table. It's in group 1, so that means it's got a charge of +1.
Okay.
Okay.
So now, what about chloride? Was there officially a rule about nonmetals?
No, there wasn't.
So what was the rule that had to get followed if none of the other rules worked?
Well, okay, the last rule, right? They all have to the numbers all have to equal 0.
Right, so they have to add up to be 0. So if K is a +1, we know that chloride is a
-1.
There you go.
Okay, awesome.
All right, so this one's going to get a little bit more complicated.
Okay.
So, because the first thing we want to do, we go down our list, we have free elements. Any free elements?
No free elements.
Metal ions. Any metal ions?
Well, if I look at the periodic table, carbon is in the non-metal side, and we keep talking about hydrogen being non-metal. So no.
All right, so no metals. So the next rule down has to do with hydrogen.
Okay.
What does it tell us about hydrogen?
Hydrogen is +1.
Yes, for all the purposes in this class, hydrogen's +1. So, are there any rules about carbon?
There's one about oxygen.
There's one about oxygen.
There's one about they all have to be 0.
They all have to be 0. So if nothing else works, we go to they all have to be 0.
Okay.
So here we've got 6 hydrogens, and each hydrogen has a +1, right?
So each one is +1.
All right.
I've got 6 of those, so that means altogether they are +6.
Right.
Okay.
So we know our carbon has to have a total of what?
Well, if they're gonna equal out to be 0, it's got to be -6.
Okay.
Total.
So you can actually do a little bit of algebra. Some of us can just see it, but if you can't, you know how many carbons.
Okay, I've got 2 carbons.
So put 2C.
2C.
So 2 carbons together has to equal what?
Okay, so 2 carbons together have to equal -6.
-6.
Okay.
So if 2 carbons equal -6, what does 1 carbon equal?
Okay, so I can divide the the 2 here. You know what? I'll just do that real quick because that's just how I roll.
Okay.
Okay, so I've got my C is -6 divided by 2 is -3.
There you go. So my oxidation number for carbon is
-3.
There you go. See, so if you can just see, hey, this is 6 and there's 2 of this, so it's -3. You can just do that in your head. That's fine. But if you're having trouble figuring it out, a little bit of basic algebra goes a long way.
Awesome. I love algebra.
Algebra's great.
Okay. Can I try this one?
Yeah.
Solo. Okay. So the first rule: free elements are 0, but no free elements. So I can skip that one. The next one is metal ions are their charge on the periodic table, but nitrogen is not a metal, so I need to keep going. Next one is hydrogen. Hydrogen is always +1, so I can start there. So I've got +1,
Okay.
and I've got 3 of them, so that means altogether I've got +3. Okay, let's see. The next one, I don't have oxygen, right? That's rule number 4. So number 5, they all have to be 0.
Right.
Okay, so if I want everything to be 0, that means I need to cancel out my +3. So that means it's got to be -3.
Okay.
Right? And so now I need to do the algebra to figure out the oxidation number on the nitrogen.
Okay, so
right.
So we can write that if we want to. We have 1N.
Okay, I've got 1N.
And that equals -3.
3.
So if 1n equals negative 3, what does 1n equal?
Okay.
Right. So if we've only got one of it, we don't really have to write out the algebra. But again, we can. It's a good way to help refresh things. It also reinforces your algebra, which should make your math teacher happy.
Okay, so then, all right, so we're good. That means n is negative 3, h is plus 1.
There you go.
Okay, awesome. Okay. Well, let's see. Let me go through it again. No free elements.
Right.
No metals.
Nope.
Okay. Oh, the next one is hydrogen. Okay, hydrogen is plus 1.
Nothing.
Okay, I don't have hydrogen. Okay. The next one is oxygen. Oxygen is minus 2.
Minus 2.
Okay, so I can do that one. So that means the oxygen is minus 2. Okay. Now I have 2 of them. So each one is minus 2. So that means altogether it is minus 4. Okay. Now the next rule, the last one, they have to be 0. Okay, so I've got 1n, so you said I don't have to do the algebra, and I can go ahead and do it in my head. I've got 1n, and it has to cancel out the negative 4, so that means it has to be plus 4. Wait a minute. I thought we just had nitrogen as minus 3.
Right, and so minus 3 is what you would expect because that's where it is on the periodic table. This is why it's important to remember. Charges and oxidation numbers, not always the same thing. Especially if we're looking at a compound like this. What kind of compound is NO2?
Nitrogen is a nonmetal. Oxygen is also a nonmetal.
Yep.
2 nonmetals are covalent.
Covalent compounds.
Okay.
So you've got a covalent compound, and because covalent compounds don't come with charges, their oxidation numbers can't be their charges. So oxidation numbers in this case are just kind of a convention we use to make things make sense, and it will make things make sense here in a bit. But for right now, just worry about if it's non-metal, it can actually be a little bit of everything. So you've got to make sure you do your math and make it work out. Because if we tried to have a negative 3 there, then our total oxidation number would be negative 7, and bad things would happen.
3 and put negative set.
Yeah. So let's.
Oh, okay. I see what you mean.
So we've got to make sure our total is 0, even if it makes our oxidation number something kind of wonky. Nitrogen especially is bad about that. Nitrogen can be a little bit of everything. Just go with the math.
So
trust the math.
I need to trust the math, but
So follow the rules first.
Yeah. Okay.
Then trust the math.
Follow the rules. Trust the math. Okay.
Yeah, because if you followed all the rules, you have to trust the math because there's not a rule about nonmetals unless they're hydrogen or oxygen.
Oh, okay. That's right.
Yeah.
Oh, okay. I think I got this.
All right.
I think I can go.
All right, if you have reached this point in the video, you should be in Ms. Copeland's pre-AP class. If you are not in Ms. Copeland's pre-AP class, you're either being really fantastically overly ambitious, or you should probably stop now and move on to other things because we may just confuse you. All right, Ms. Copeland's pre-AP class. We've got to deal with polyatomic ions. Polyatomic ions are not really any more complicated than what we've been doing. The thing is, you've got to keep track of more stuff. So we're still going to start by going through our rules. So let's go through our rules. So which rule are we going to get to first?
All right, so no free elements.
No free elements, we can skip that.
Metals.
Metals.
We got a metal ion.
So what's our metal ion?
Same as the periodic table, so potassium is plus 1.
Okay.
Okay.
So which rule are we going to run into next that's relevant?
Let's see. No hydrogen. Oxygen.
Okay, oxygen's always going to be...
Oxygen is always going to be minus 2.
Okay.
So, okay, we've got 3 of them. All together, that means it's minus 6. All right. Here, can I do this? Can I bring down that plus 1?
Yeah.
Okay.
So we know that all of them together have to equal what?
They all have to equal 0. That's the last rule.
All right, so in this case, yes, earlier if we only had one of something, we didn't really have to do the algebra. There's too much stuff to keep track of here. So what we have to remember is what do potassium plus chlorine plus oxygen all have to add up to?
They all have to equal 0.
All right, so we know that plus 1
Okay, plus 1.
plus whatever chlorine is.
Plus whatever chlorine is.
So we can just put Cl.
Oh, okay.
So we can use Cl like X. Plus oxygen, which we know.
Plus oxygen, which is
negative 6.
6.
All has to equal.
And then all has to equal.
Alright. So if we're solving this algebraically, what's our next step?
Let's go ahead and simplify the negative 6 and the 1.
Alright, so if we combine plus 1 and negative 6, we get.
Alright, so we get Cl minus 5 equals 0.
Okay, now how do we get Cl by itself?
Let's go ahead and add 5 to both sides. So I've got 5 and then plus 5.
And so Cl's oxidation number has to be?
Cl's oxidation number has to be plus 5.
Plus 5, yep.
Okay, so like that.
There you go.
Okay, so if I keep going, so it's got to be plus 5, and I can kind of keep it going so it's consistent. Okay.
Like I said, polyatomics not that much worse, just a little bit more to keep track of. This is where algebra becomes even more important.
Okay.
All right. So wait, what's different? This looks a lot like the one we just did.
It does look a lot different.
So what's changed?
Okay, ClO2. The last one we had was O3, so we had 3 oxygens.
Okay, so this one's got 2 oxygens. So what would we name this?
Okay, it's potassium, ClO2. All right, periodic. Well, here's my polyatomic chart. It is potassium chlorite.
As opposed to our last one, which was potassium chlorate. Remember, ites always have less oxygens. And we're actually going to find out in a second. Ites also tell us something about oxidation numbers. So let's do the same thing we just did.
Okay. All right. No free elements. I got a metal, so it's plus 1. No hydrogens. Oxygens. I've got my oxygen. Oxygen is minus 2. I've got 2 of those, so that means overall it's going to be minus 4. Here's my plus 1 right there. Okay, so this looks a lot. This looks really close to the last one. So maybe I can set it up. I've got 1 plus whatever my chlorine is, plus I've got negative 4, and all of those have to equal 0. That's my last rule. Okay, I can get my my 4 and my 1 together, so that's going to be minus 3. So Cl minus 3 equals 0. And then if I go ahead and add 3 to both sides, Cl equals 3. So now we're saying that chlorine is plus 3. But before, it was plus 4.
Plus 5.
5.
Even. Yeah. So chlorine, like nitrogen, can have a number of things, which is why we've got to watch out for it. So what you'll notice is your ites have less oxygen because your ites have a lower oxidation number than your ates did. Keeping track of why which one is which is a whole other story, but be aware, ites will have a lower oxidation number. All right, so now you can work on the next part on your own.
Ding.